Hey, good evening. It's October's edition of SpaceBar. Welcome wherever you are. I'm Dallas Campbell.
And I'm Suzie Imber. And this edition of SpaceBar, of course, is in the new format. So we have a 1-hour show that you can watch on YouTube, but do post your questions. You can post individual questions. You can send in videos if you have a video question. So do type things in the live chat as well if you have. If you want to share with everybody who you are, where you're from, if you're new to the SpaceBar, do introduce yourselves. We'd love to hear from you. And of course, after SpaceBar, there will be the after party, which will be on Zoom. So don't forget to join us there.
You look quite Jesus-like, actually, with that great solar flare behind you. I mean, first of all, I was kind of worried about your sunburn that you were going to back again. But then the kind of religious iconography that's sort of...
It's just because my hair's been sticking up today, and that's why I picked this, because it's quite iconic for my day where my hair has been vertical. I don't know why.
We were just discussing before we came on air that maybe we should have kind of AstroAgency SpaceBar branding as our backdrops. But the more I think about it, I like our slightly more random choices. Well, listen, thank you very much for joining us. We're going to be with you for the next hour. We've got 3 terrific guests who I'll introduce in a moment. First of all, a huge thank you to Viasat, who are our sponsors. Thank you very much for sponsoring us. Keep on sponsoring us, please, Viasat. Thank you very much indeed. Have we had anyone from Viasat on the show? We should get them on and thank them properly.
Yes, well, we can work on that. We also, though, we have space news happening, of course.
Of course.
We will stop and have some space news. That's with Torsten and Vix. There they are. Hello.
Hello, Torsten and Vix. Looking forward to that as ever. Right, we've got 3 guests for you as ever. Our first guest, I shall introduce them and then we'll introduce them properly a bit later on. Les Johnson, we've got author, physicist and NASA technologist who, there he is, Les, give us a wave. Les is in Huntsville, Alabama, which is basically the kind of home of rockets, Huntsville, Alabama. That's kind of where it all started from. Not only is he a NASA technologist, he also writes fiction books as well, and he's going to be talking to us. We're going to be hearing a little later from Sargunn Brar, who is not with us, but she's done an interview with us. So Sargunn, I'm very excited. She is a Canadian author, very talented, and illustrator, and she is going to be discussing her book, The Planet's Story. So I'm very looking forward to hearing from her. Who else have we got? What else have we got, Suze?
We've got a startup spotlight, of course, as ever. And today we have Portia Bircher, who leads the UK Space Agency's business support program. Hi there, Portia. Looking forward to hearing from you a little bit later as well. Of course, we also have Rebecca from AstroAgency and Ali, and they will be monitoring the questions live. So as you type in questions and looking at the chat, there's Ali. Hi, Ali.
Hi, Ali.
Hello, and there's the chat. It's busy already, so hopefully we'll get some great questions from our guests.
You know, we've got like a video thing. People can do like video questions as well. Does anyone ever do that?
Oh, we've had loads. Yeah, and you can. There's a link underneath the video if you do want to send a video question.
Can someone do some video questions? I don't think I've ever seen anyone do a video question.
We have had a few.
Our SpaceBar, so...
That's so, cool. Link to do that's underneath the video, but the live chat's in full steam.
Great, full steam ahead. Okay, so we've got Sargunn, we've got Portia, but first up, we have got all the way from Huntsville, Alabama. It's Les Johnson. Les, welcome.
Thanks. I'm glad to be here.
And now, listen, I heard a rumor that you sent over your slides today, and you thought you were doing an hour slot, and you sent over 120 slides.
It's a bit of an exaggeration.
We may have to compress it slightly. We've got 8 minutes.
I'm a little bit of a talker, so I'll try to condense it down to the 8 minutes so we have time for question and answer. That'll be great.
But listen, thank you so much for joining us. It's an absolute pleasure, and I'm going to hand over the floor to you.
All right, real quick introduction. Yeah, I'm Les Johnson. I am a physicist by education. I do work at NASA, but I'm speaking in my private capacity today as an author. I write popular science and science fiction books. In my day job, my expertise is advanced in-space propulsion. That's how you get from one place to another after you get off of a planet. And in my career, I've given a lot of thought about how we might actually go to the stars. Last fall, Princeton Press published a book that I wrote, a pop science nonfiction book called A Traveler's Guide to the Stars, which is on that very topic. But what I want to focus on today is the challenge of interstellar travel, truly going to another star, not in a science fictional way, but the way that physics will probably allow us to do it someday in the future. And just to really quickly run through some of those challenges. So the first thing I want to mention is until about the 1990s, we did not know scientifically that there were exoplanets. The first real scientific evidence happened in the 90s. Prior to that, it was all science fiction and speculation on the part of scientists. But they kind of knew our solar system wouldn't be unique and there'd be other planets out there. But it was thoroughly explored in science fiction, and that's what got me interested in studying physics, is the idea of actually going to one of these exoplanets. And here are just some of the things that inspired me as a youth, just as a flashback for those of you who might have seen some of these shows or read some of these books. But next slide. So when you talk about going to the stars, we know that there are a lot of destinations nearby. We've discovered over 5,500 just in this little part of the galaxy that's very close to us, in this immense galaxy, which means there are probably statistically about 400 billion exoplanets in the Milky Way galaxy alone. So there are lots of possible places to go, and quite a few in our relatively close neighborhood. But as you'll see, that's not really that close. Next star. How do we get there? That's the question people started asking. After we started finding these exoplanets, characterizing their orbits, finding out how big they are, people want to know, can we ever really go? Star Trek says it'll be easy. Star Wars says it'll be easy. It won't be easy. But it's not impossible. Nature is going to allow us to do it. We just have to figure out the engineering. Next slide. Let's talk about that distance. The nearest star system, the nearest star you can actually see, is Proxima Centauri. It's about 4.2 light years away. What that means is light traveling at 300,000 kilometers per second takes over 4 years to reach our eyes from that star. Just for reference, our sun is about 8 light minutes away. So the sun, it takes light 8 minutes to get to the Earth. That is a long way. In fact, I would contend astronomers don't really understand the distances, because as you can see, when you put it in kilometers, it's a 40 with lots of zeros after it. What does that mean? We don't intuit distances like that, like we do here at the Earth. I recently got back from my first ever trip to Poland. It was a wonderful trip. I lectured at the European Rover Challenge about my book, met some wonderful students. It was about a 7-hour flight. If you could fly continuously on an aircraft, you could fly around the world in just short of 2 days. The space station does it every 90 minutes. So we know what these distances are. Next slide. But when we start talking about the size of the solar system, and you start talking about the distances from the Earth to the sun, for instance, that's 150 million kilometers. It takes 8 minutes for light traveling that fast to reach the Earth. And astronomers don't like dealing with numbers that are all zeros when they're just chatting. So they came up with a unit called an astronomical unit. And an astronomical unit is the distance from the Earth to the sun shrunk down to 1. So 1 AU, 1 astronomical unit, is this 150 million kilometers, okay? So in less scale, to make the illustration I want to make, let's assume that 150 million kilometers is shrunk down to a unit that we can all measure in our daily lives and experience, which is about a meter, all right? So 1 astronomical unit, 1 meter, the Earth to sun distance. On that scale, next slide, the distance to the farthest planet, Neptune, is about 30 astronomical units. 30 times 150 million kilometers, or in less units, 30 meters. So it's on the other side of the wall, in the far end of the room, wherever you are, right? Okay, it's not terribly far away, but it takes our spacecraft about 10 years with rockets to go that distance. 10 years to go 30 astronomical units. Well, on this scale, next slide, the nearest star is 269 kilometers away. 269,000 meters, where each meter is 150 million of our kilometers. That's an enormous distance. It's unfathomable. We have no idea what that really means experientially, except that if it takes light 4 years to get there, it's going to be really hard for us. Go ahead and go to the next slide. On this next slide, we have launched our first interstellar probe. They're called Voyager. They were launched in 1977, before many of your viewers and listeners were born. They are now at about 150 to 160, there are 2 of them, astronomical units. And they've been traveling for over 40 years. If they were going in the right direction, they would reach the nearest star in 70,000 years. I don't call that a practical interstellar voyage, but it is an interstellar voyage. We are technically becoming an interstellar species by sending probes to the stars. It's just going to take a long time for them to get there. Next slide. The bottom line is, in terms of technologies, conventional rockets can't go fast enough to reduce this trip time to anything practical, which I define as being less than 1,000 years. I pick 1,000 years because There in Europe, where a lot of your viewers are, you have cathedrals and archaeological records going back 1,000 years. We have very few of those here in North America, but you do. And so I can imagine launching a probe today, and our civilization 1,000 years from now would remember to turn on the radio to get the data back. And if we can get that down to hundreds of years or even decades, then we might be able to do it. Rockets won't make that work, not even nuclear rockets. They don't have the efficiency and the performance to make that happen. Next slide. There are types of rockets that will, and I discuss these in my book. Fusion propulsion, the energy that powers the sun. If we can put that on a spacecraft to power our spacecraft and give it propulsion, we could get trip times of hundreds of years to the nearest star. Nuclear pulse rockets, which are a very fun concept, something I hope we never build, and involves detonating lots of hydrogen bombs. Not a good idea. And then antimatter rockets, kind of the ultimate rocket with the ultimate fuel in nature, where you take advantage of Einstein's equation, E equals mc squared, to get all of the energy out of matter. Next slide. My favorite, let's go ahead and skip this. I'll talk about this in the chat, perhaps. Next slide. Ask me about antimatter in a banana, and I'll tell you all about it. Are there other ways? And the answer to that question is yes, there are. My favorite on the next slide is something called a solar sail. And a solar sail is where I've spent a large part of my career working on off-board propulsion. And the idea here is that if you put a large lightweight reflector in space, like a sail on a sailing ship, but instead of reflecting wind, you reflect light, and you shine sunlight on this, and it's very large and very lightweight, it starts moving because light has momentum. And as the light reflects from the sail, it makes it move. And what I recommend we do is we build these really big lasers, more powerful than anything we can build today, and use the pressure of sunlight to send our probes to very high speeds to go to other stars. Now, if we skip ahead about 2 slides, I'll just give you keep going. I'm going to give you one thought to drop off on here. And that is that let's assume we're wildly successful. We figure out how to get to the stars. We figure out how to take a voyage within a human lifetime, 40 to 50 years. Nature says it's possible. Let's assume we succeed and we send our first robotic probe that is the size of a pineapple, about 1 kilogram. Next slide. We have to be really careful, because if we don't slow down and it's a flyby mission, and instead of flying by the planet, we hit the planet, the energy contained in that pineapple, just from the energy of its motion, the kinetic energy, would hit the planet with the force of 7 Hiroshima-class atomic bombs. Just from how much energy of motion the pineapple would have traveling at those speeds, at 10% the speed of light. So if you're not careful, our first interstellar voyage could be a declaration of war, not a good first step with any extraterrestrials. So in conclusion, if you go to my last slide, I have up here, keep going, about how to reach me. I have my contact information, my books, both my science fiction books, which I write for Band Books, they're pretty widely available, and my latest nonfiction book, which is all about interstellar travel. So there you go, my hour-long lecture condensed to 9 minutes. How's that?
You understand time, deep time and PowerPoint time, which are kind of the same sorts of things. Honestly, the reason I got interested in space when I was a kid was exactly listening to this kind of stuff, listening to people like yourself talking about how are you going to get to the stars. I seem to remember, was it Daedalus? Wasn't there a big star probe called Daedalus? And they were talking about in the 1970s or something that was going to get us to the star. Whatever happened to that?
Daedalus is not alive and well in the sense of reality, but that was a project of the British Interplanetary Society, of which I'm really pleased to say I'm a fellow of the BIS, big supporter of that group. And they've done an updated study of Daedalus, looking at what a fusion-driven starship would realistically look like if we ever get the capability to build a compact fusion reactor, which is something we really don't know how to do right now. But they've actually done a very good design study, and I think it's kind of the go-to reference in this entire field for what an interstellar starship driven by fusion propulsion would look like. So I encourage folks to go check out that.
Daedalus. Who is Daedalus? Icarus's son?
Icarus's father.
And
he was the one who put the wings on and flew toward the sun and escaped. Where his son was didn't pay much attention and flew too high and melted the wax and died.
That's happy stories. Happy stories.
Can I ask you a question, Les? When we're talking about interstellar travel. Most people outside the kind of the space world, if you like, will have heard of Elon Musk and will have heard of Elon Musk's mantra about we're going to make human beings an interplanetary species. What do you think of that? I mean, are you sort of on board with his plans and the kind of stuff that he talks about?
Well, I don't know that I'll endorse his specific plans, because I think a lot of people have ideas of how to do this, but I absolutely do. I really believe that I make the moral value judgment that life is good and preserving life is a good thing. And I think we ought to be using space technology to help solve our energy and climate problems here on the planet. But while we're doing that, we need to be taking life out into the universe, because it looks like we live in a cold, dead, empty universe, at least nearby. And life is a precious thing that needs to be preserved. And I don't mean just human life, I mean all life. So I think we ought to be expanding our biosphere to Mars, to other planets, and eventually to other stars. So absolutely, I'm on board with that.
I was chatting with somebody who was thinking years ago, who was thinking about this idea of a 1,000-year journey to the nearest star. And the most entertaining discussion came about when they said, it's fine, you could go and you could expect many generations to be born and live and die on this spaceship, and there's lots of complexities associated with that. But she said, what happens when, after 500 years, technology's moved on and you get overtaken? How mad would you be if you and your friends and your family have been on this thing for 500 years and humanity then just sends something that just calmly passes you in the outside lane? That, I think, is a problem. I thought that was quite an interesting idea.
It's a good idea, but then you mentioned Voyager, Les, and Voyager sent up two, vinyl records from 1977.
Yeah.
And they're just past the kind of heliopause. Presumably, we could do something very different and up to date now. But
well, no, yeah, I think that those probes, if they're ever intercepted, which is extremely unlikely, they're going to be cold, dead, and hard to distinguish in the background of all the stuff that's out there, because their power source will soon be depleted long before it gets to another star. But there are people who are looking at how we might do this. The Breakthrough Starshot is a privately funded venture to launch these laser light sailcraft to the stars. I've consulted with them a few times, and they're already talking about how they would put something similar on board the spacecraft. But of course, it'll be small and digital as opposed to a record.
Do me a favor, Suzie and Les, you're physicists. I have never understood how a massless particle like a photon can propel an object.
Well, it's this. It's one of those vagaries of people wave their arms and say, "Oh, it's quantum mechanics." Well, in this case, it really is. The photons have no rest mass, which means but they do have momentum, and it's been measured. And what happens is the energy of the photon, when it reflects from the sail, it gets slightly redshifted, which means it loses a little bit of energy. And that energy is converted into the motion or the kinetic energy of the sailcraft. And it involves something called the Planck constant. And so it's there, it's real, it's been measured, and by golly, let's use it to take us to the stars.
Oh, that's a great note for us to hand over to Ali. I think Ali's raised his hand there. Are you in?
Yeah. It's a great conversation going on after your first slide, Les, all around the best sci-fi shows to watch now. People recommending some of the new Star Trek shows, and I think the cartoon is at Lower Decks.
Rick
Rebecca,
and Morty.
Rick and Morty?
Still Rick and Morty,
Becky, is there any good questions from the chat you'd like to highlight?
Yeah, we've got a really great question from Rory Phelan. So, Les, what are the bottlenecks in engineering that are preventing us from designing big enough lasers for solar sails right now?
Well, the bottlenecks in engineering, I think those bottlenecks are being knocked down. I've just seen a demonstration of a 50 kilowatt solid state laser that when I began my career would have been impossible to build. We would have required something the size of an industrial building with all kinds of hydrogen fluoride gas. And these things are now fiber optics on the back of a truck powered by a diesel generator. And there are groups looking at how you can take multiple fiber lasers and phase lock them to get the power levels we need. So I think the engineering impediment is going to be scaling. And how do these things scale, and how do you get the phase lock and the power to them simultaneously? The bigger challenge is going to be finding a sail material that can withstand that much energy and reflect it from it without absorbing enough to burn up. Current sails absorb about 7% of the incident energy, and at those energy levels, that would be enough to vaporize the sail. So the technology advancements I believe we need to really focus on are on the sales side of it right now to catch up with where laser systems are going.
Brilliant, thank you. We might have to come back to the banana. Lots of people are curious about the banana.
Oh, yeah.
So.
Banana.
Stay tuned.
Stay tuned.
Nice little cliffhanger. People will stay because they'll want to know all about the bananas. So stick around, lads.
Bananas, yeah, absolutely.
We're going to come back to you in a moment. We're going to talk. We're going to talk to Sargunn, who's. I'm very excited to hear from Sargunn, who is, I think, hopefully watching in Canada with her school friends. I think maybe, hopefully, if so. Nice to have you with us. But before that, we're going to head over to Vic and Torsten for the space news.
And good evening. Welcome to the October edition of SpaceBar News. We kick off with an announcement from the International Astronautical Congress, which took place in Baku in Azerbaijan 2 weeks ago. The IAC is the world's largest space event where thousands of people from all over the world gather to share their ideas and achievements in space exploration. Now, this year, the IAC was a celebration of diversity and collaboration, where more than 5,400 delegates from 132 countries attended the Congress, making it the most diverse IAC ever. And thanks to a free live streaming, another 50,000 people joined online from around the globe.
Congrats to Anthony Baker and his team. Satellite VU has released the first light imagery from its thermal imaging satellite HotSat-1. As it announced, it moves into the commercial operations now. So HotSat-1's initial images provide unique insights and new data layers across various geographical locations. In Canada, the imagery reveals active fire fronts while enabling the monitoring of rail logistics in Chicago. And in Las Vegas, the high-resolution observations shed light on urban heat islands, while also highlighting the benefits of industrial activities monitoring in Cushing.
And next up, the UK Space Agency has announced a huge funding boost for innovative space projects that could make the UK a leader in space technology and applications. The National Space Innovation Programme will support up to £65 million worth of projects that aim to tackle challenges such as using satellite data to combat climate change or making space missions more sustainable. The programme is open to proposals from British organisations that have bold and creative ideas that could revolutionise the space sector. So what kind of projects are we talking about here, and what have we already seen being funded, Torsten?
Since its launch in 2020, the National Space Innovation Programme has provided UK organisations with over £25 million in funding, including Satellite VU, which uses the support to develop the first middle wavelength infrared satellite launched in June 2023. And to come back to the initial £65 million statement, the first tranche of up to £34 million funding is open to proposals that, while drive innovation, accelerates the route to market and catalyze investments into the UK space sector. However, UKSA will split the remaining funding across further calls in 24 and 25, with projects running until March 27. So great news for the UK.
Okay, the US Federal Communications Commission takes first space debris enforcement action. So DISH, which is a company that provides TV services, had to pay a fine of $150,000 for not moving its EchoStar 7 satellite high enough when it was done with it. The satellite was supposed to go into safe orbit, which is 300 kilometers above the geostationary orbit of 36,000 kilometers, but it only went to 122 kilometers, and this made it a potential hazard for other satellites and space junk. Torsten, is this a breakthrough settlement, do you think?
Absolutely. This is one of its kind, and I hope it will not remain that. The FCC Enforcement Bureau Chief Lowen Eagle said, as satellite operations become more prevalent and the space economy accelerates, we must be certain that operators comply with their commitments. This is a breakthrough settlement, making very clear that the FCC has strong enforcement authorities and capabilities to enforce. It's vital vitally important space debris rules. My point to take here are, it is great that enforcement takes place, but a fine of $150,000 for potential hazard as a multi-million-dollar businesses in a geobelt, I see that as a sign. Let's put it that way.
Okay, so the final story, this is one for you, Dallas. Axiom Space partners with Prada for lunar spacesuits. So NASA has teamed up with the Axiom Space and Prada to design the lunar spacesuits for the Artemis 3 mission to the moon. Yep, you heard that right. Prada, the famous fashion brand, is going to make the spacesuits look stylish and functional. The spacesuits will be based on NASA's XEMU design, which offers more flexibility and protection than ever before. They will also use Prada's experience in materials and technology to create solutions for the harsh lunar environments. The spacesuits will be called XEMU, and they will enable the astronauts to explore more of the moon's surface and conduct scientific experiments. Well, that's it from us on SpaceBar News, and we will see you on the next orbit. Back to Dallas and Suzie.
You kind of think it's a PR exercise, isn't it? The whole Prada spacesuit thing.
I knew you were going to pick up on that one.
But also, as soon as they say, "Oh, we're going to make them look really fashionable," you just know they're going to look dreadful. Like the old Apollo suits that were designed by Playtex, Playtex who make kind of bras and girdles. So there's always been a kind of connection, I suppose, with the fashion industry.
You hated the most recent ones, didn't you?
I did. Don't get me started. Anyway, I'm not going to get started on my spacesuit rant. Hey, listen, we've got another bit of news, just quickly. Suzie, tell everyone about the news, AstroAgency and the British Interplanetary Society.
Dasha won one of the Arthurs last week, and I'm going to read the citation to you. For her inspiring demonstration of resilience in the face of war, personal tragedy and unrest through the pandemic, and winning several new space contracts. So well done, Dasha. Big round of applause to you. Congratulations to AstroAgency. Great to see you recognised. Fantastic news.
The Arthurs, by the way, the British Interplanetary Society, the world's oldest space society, which is 90 years old this year. They have their little Oscars, which is called the Arthurs. So there we go. I think you won did you win one once, Suzie? I think maybe you did.
Yeah, I did. I won one for media once a few years ago. And I think SpaceBar was nominated last year or the year before as well.
They were, but they won this year. So I guess Dasha is representing AstroAgency. So congratulations. Right, moving on. We've got Startup Spotlight in a bit. But before we do that, we're going to go all the way to Canada because we've got Sargunn, Sargunn Brar, who's going to be talking to us about her new book.
Hello, SpaceBar fans. My name is Rebecca, and I'm the bar manager here at AstroAgency, and I'm thrilled to introduce a very special guest this month, Sargunn Brar. Sargunn is a Canadian student that wrote a book called The Planet Story, which talks about all of the planets in our solar system by comparing them to their personalities and the people in her family. And incredibly, this book has made it to the shelves at Amazon. So welcome, Sargunn, to SpaceBar. Do you want to start us off by telling us a bit about yourself and what inspired you to write a book about the planets?
So I'm Sargunn, and I'm a student at Glendale Sciences and Technology School, and I am 12 years old. And some of my passions are canvas painting, rock painting. I love playing sports like basketball, discus throw, and shot put. I love going for walks, and obviously I love reading and I love writing. And what inspired me would probably be my parents, because the day I started writing and drawing, I showed this to my dad, and my dad said, "You should probably write a book." And I got inspired by my dad, and I'm like, yeah, let's go for it, and let me try to write a book. And when I showed my mom too, and she said, "We should probably get this published right away."
Well, she was right, and so was your dad, and you did a fantastic job. Can you tell me more about your book itself?
So my book is about planets, and it's just an easy way for kids to learn about planets. I've added emotions, traits to each planet, and kids can relate those traits and emotions to a family member.
I love that idea. I also have my copy of the book here. It was sent to me as a gift last year, and I absolutely love it. Overall, what made you so interested to learn about space and the planets? What made you choose that as your topic for the book?
So as a kid, I was always interested in this kind of stuff. I would always wonder how it becomes day and how it becomes night, and I just wanted to learn. So I asked my mom Mom, can you teach me something about planets? And she showed me a video, and I instantly fell in love with planets. And I just think the reason why I wrote my book is that I can help kids learn planets in an easy way. And I just think planets is a really unique topic, and I can just make it an easier way for kids to learn.
And I think you absolutely did. It's a funny book. It's interesting. You're learning as you go. Big fan. How did you do the research for your book?
So since it was COVID, I couldn't really go out to the library. I had to read some of the books I had at home about planets. I also researched on Google. I also since every time I used to research on Google, I would get complicated answers. So I just took some knowledge from that, and I added all the fun and the creativity I knew to the book.
It's a winning combination, I can guarantee. So a question for you is, did you draw the planets based on your research, or did you just add your own ideas and imagination? Because I find it quite interesting how you drew Uranus, for example, on his side with the sleeping mask, and that Uranus is on its side as well. So I just thought that was very interesting. Did you do that based on your research?
For some planets, I didn't have to research, like Earth, the Sun, and the Moon, because I already knew how they look like, and just I knew some info about them. But for the other planets, I had to research. I had to look up some drawing images of them, but then I also added my efforts to it too.
Fantastic. So do you think that your book will inspire others, or do you hope that it will inspire others?
It's already inspiring others. When I wrote my book, I was sent to read to other classes, and kids would also ask questions. And I just think they're already being inspired. And I was also requested and invited to read my book to a different school. And I was also promoted a young author and a young reader at that school.
Amazing. Congratulations. What do you hope that young readers will learn from your book?
I just think that they will just find it easier to learn about planets if they have someone to relate to with the planets.
Going forward for you in the future, do you want to continue to learn about space or science?
Of course. I just think science and space is like really fun and unique, and I just want to continue to learn more about it, and it just seems fun to learn about.
It's very fun to learn about. That's why we're all here. You are right. Do you want to write more books in the future?
I've already written 2 books, and they're just ready to be published. So one of them is about fruits. So basically, fruits are fighting over who's the healthiest and who isn't. And the other book is about spring, summer, winter, and fall. Just a little story about them too. So I'm just trying to find another publishing company, and I will get those published right away as well.
Good for you. I can't wait to see those ones as well, especially if it features your artwork. All right, one final question for you that is special to SpaceBar fans, because we're all pretty crazy about aliens. So if you met an alien on another planet, what would you say to them?
So if I met the alien on Earth, I would assume that the alien is good, and I would say to the alien that, hey, come to my house and let's do a painting together.
I think that is the most fantastic message to deliver to an alien. Well said. That's incredible. Very brave and very smart. And I think that's very, very cool. So I think that sums up our SpaceBar questions for you today, Sargunn. It's been an absolute pleasure having you here this month. And I know we speak for the entire space community in saying that we're so excited to see someone of your age writing books and inspiring other students to learn about space. And for all of you SpaceBar participants that are out there and you want to learn more about Sargunn's book and to see all of her amazing artwork and other projects, please visit her website. We'll be sure to include the link below. Thank you, Sargunn, for joining us on SpaceBar. It was an absolute pleasure. And back to you, Dallas and Suzie.
Thank you very much. Thanks, Sargunn. I hope you're watching this, Sargunn, in Canada, wherever you are with your friends. Hey, I've got questions. You know what my question is, Suzie?
Go ahead.
My question is, she's writing a book about fruit, which is the healthiest and which is the unhealthiest. Now all I can think about is what's the most unhealthy fruit?
I don't know. I'm eating grapes right now. So
they've got to be healthy. I'm wondering if it's Les's radioactive banana.
There's a really weird space fruit theme going on this evening.
Is there?
Yeah.
Do we have a few more questions? I think we've got for Les, don't we, Ali?
We've got some nice comments as well, I think, that Ali was going to just mention briefly.
Yeah, just loads of lovely comments from the audience just saying how impressed they are by Sargunn and her writing, and can't believe that she's only 12 years old as well.
Just looking at Sargunn's book, actually, it was so lovely. And they paused on one of the pages, which is about Uranus, and it said Uranus likes to sleep in the daytime, which that's me. I can relate to that. I could.
Brilliant. Yeah, we'll do some more questions with Les shortly.
Great. Before we do, though, of course, it is time for the Startup Spotlight. And so we're going to hand over to Andy Campbell. Andy, over to you.
Good evening, everyone, and welcome to SpaceBar's Startup Spotlight. Tonight, rather than profiling a new startup company, we're delving into the world of business support for budding space-based entrepreneurs. And I'm delighted to welcome Portia Bircher, the Business Support and Growth Manager at the UK Space Agency Accelerator, a programme instrumental in supporting the growth of space businesses across the UK. So let's go for launch and give Portia a very warm SpaceBar welcome and hear all about the business support on offer. Over to you, Portia.
Why does the UK Space Agency invest in business support? Well, the UK Space Agency has had a business support programme since 2016. It was set up to identify and support growing space businesses all around the UK. The agency supports the UK space sector through delivery of all its programmes and underpins the goals and the ambitions of the National Space Strategy through our value proposition. To support business, you also need business support to help innovators see themselves as entrepreneurs and to help them to commercialise their products and services and developing sustainable business models. I've led the UK Space Agency's business support programme for about 5 years and worked with Entrepreneurial Spark to deliver the pilot programme. Following the success of the pilot, where the companies that we supported raised over £5 million worth of investment and created over 80 new jobs during the 18 months of the pilot, the UK Space Agency Accelerator was given the go-ahead to deliver a 3-year programme, and this time it's bigger and better than before. So our accelerator isn't just limited to a particular technology or segment, upstream or downstream. We want to encourage more entrepreneurs and anyone who is or has developed space applicable products and services to explore if the UK Space Agency Accelerator is applicable to them. And I'm almost sure that if they're willing to engage with the programme, we certainly can. The UK Space Agency Accelerator provides a focused package of support, and we have programs for businesses at all early stages of development. Explore is perfect for those making their first steps into the commercial space industry, who may see themselves as inventors, but with a desire to build scalable businesses. They may also be working in adjacent sectors, but see the potential for their products in space. Leo is ideal for those who have a proof of concept in place, and they are at the stage of embarking on their business journey. The offering for Leo participants is, as much as we can make it, a bespoke programme, and it caters for their needs to scale at pace. Geo is for those with an existing strong market traction, but who are now looking to reach higher. So what does the UK Space Agency Accelerator provide? Well, every participant is offered one-to-one sessions with a business growth and technical enabler. They will challenge the entrepreneurs to identify the actions that they need to take in order to make progress on their business and hold them to account for taking it. Where appropriate, they may well be able to make relevant introductions. There's also access to mentors, weekly webinars covering a whole host of business-related topics, pitching practice, advice on access to finance and networking opportunities. But in addition, we have the Orbit series and Trajectory. The Orbit series underpins every programme of the UK Space Agency Accelerator. It's delivered online and covers everything from business leadership and mindset to technology and customer acquisition. Participants get access to a series of overview videos where they can decide if they want to explore that particular topic any further. They can then sign up for a live 90-minute web-based workshop where challenges can be discussed in small groups with one of our consortium experts. Orbit is really the perfect learning companion to the entire accelerator programme. Trajectory is a roadshow of in-person networking events across the whole of the UK. It's designed to bring the accelerator participants, alumni, stakeholders, and regional ecosystem together to discover opportunities and cement long-lasting networks. The aim is both to inspire and promote greater ambition and engagement across the UK space sector. So what have we done so far? We've delivered one Explore cohort of around 30 participants this year. We've just welcomed another 30 Explore cohort in September. We brought on our first Leo and Geo cohorts in May of this year, and they're due to finish in November. We've already supported them to raise more than £500,000 in investment and grant funding, and there's way more in the pipeline. We've opened our applications for our next Leo and Geo programs. They're due to be delivered in the new year. But as applications are open now, the QR code on the screen there will take you to our website, and it will give you much more information about our programs, and it will give you the opportunity, obviously, to apply. So the UK Space Accelerator, with our delivery partners, is very much purpose-led, and this includes doing our bit to make the UK space sector more diverse and delivering our programs to a more diverse group of participants. And I think there's been great work done to raise awareness and address diversity and inclusion in the UK space sector so far. But to give you an example, within the Space Accelerator, we actively seek to support entrepreneurs from every region and every nation of the UK, as well as targeting percentages of our cohorts, for example, from diverse cultural backgrounds and more female founders. We do quite well, actually, attracting participants from a wide variety of cultural backgrounds, but we're still struggling to attract more female entrepreneurs. So that's why we thought, by coming here this evening to talk at this SpaceBar about the UK Space Agency Accelerator, we could tap into your ideas as to how we might reach out to more female founders. They might be in adjacent sectors or relevant verticals to space. We want your help to understand how best we can support them, because we've got the ideal conduit to help them either break into or progress in the UK space sector.
Portia, thank you so much indeed for coming on and giving us a really thorough explanation of the Accelerator programme that you've got. I've only got time for one question this evening. I think there might be some questions a little bit later on if we've got the opportunity, but clearly your programme is geared towards making the UK a hub for space entrepreneurship, which is fantastic. And you've already achieved some significant milestones raising capital for companies and job creation. But as you know, the global space sector is rapidly evolving, new players, new disruptive technologies. And I'm quite keen to hear from you on how the UK Space Agency Accelerator programme is planning to adapt its strategy to ensure that it not only nurtures the startups that you work with, but it also makes them globally competitive and resilient in this fast-changing landscape.
Yeah, thanks, Andy. I mean, I think that's one of the reasons why we run the three programs. So the way that I like to look at it is kind of an escalator of support. So it's sort of like we do support the very early stages, but then we do then go and support the later stage to actually sort of like look at how they can scale. And I think that's sort of like it's representative of the UK Space Agency's strategy in terms of sort of like, you know, our programs, all our programs are designed. We react to industry. We try to deliver what industry, you know, tells us that they want. You know, in the space sort of like roundup, you know, it said about the National Space Innovation Programme. So that's one of the just one example of how the agency is actually reacting and making the UK space sector sort of like competitive and competitive and, you know, globally you know, being able to commercialize. I mean, and another example of that is that we've got a lot of we've got a lot of information coming out in the future around where we've identified a gap of we're engaging with venture capitals and angel investors to try and get those kind of organizations involved and making our companies more investable.
Yeah, fantastic, thanks. And a really critical programme to give those inventors and entrepreneurs the support they need to have not only a great product into the marketplace, but a sustainable business as well. I'm sure we're going to have some time afterwards for questions from the audience. If anyone is listening and has any questions, please do pop them into the chat. And however, as they say, you can join us for more chat in the after party. So for now, thank you, Portia, for coming on for this evening's Startup Spotlight. And we'd like to wish you all the very best of luck in recruiting for your next programme. Just a reminder, folks, if you or anyone you know would be interested in coming on a future Startup Spotlight, please do get in touch with AstroAgency. That's all from me this evening. So back to you, Dallas and Suzie.
Thank you very much, Andy and Portia. Can I do a bit of self-promotion here? If you want to pitch something, excuse me, I'm running pitch presenter therapy courses. If you're terrified of pitching and need therapy, I can help.
Or any kind of presentation, right?
Yeah, I've been helping kind of academics and startup people and people who are pitching for various things, because it can be quite nerve-wracking pitching if you've actually have an idea that you really passionately believe in, and you've suddenly got to stand up in front of someone or write it down and sell it. It's not a natural thing to do. It can be quite terrifying, and so I've been helping people. So if you need a hand, give me a shout.
Can be that way, actually. Like any time you stand up in front of a big crowd can be intimidating. So yeah, reach out to Dallas if you need some help.
Yes. Questions.
Yeah,
Do we have more questions?
I think everyone wants to know about the banana, as what I've gathered so far. But Ali, why don't you pop up? Or Ali, there you are.
Don't pop up the slide yet. Let me give some quick background before you bring it up.
I can't read the question. Oh, here we go.
There we are. Becky, what's everyone saying about the banana?
Yeah, I think that's what we really need. Everyone wants to know about the banana, the antimatter, anything you can tell.
Can I guess what it is?
Okay. Just real quick.
Is it something to do with bananas being radioactive in some way?
That's exactly right. But don't be afraid. Still eat your fruit, whether it be a banana or a grape. I like all of the above. Radiation is a natural part of our environment, right? And when I think about going to the stars, we think about exotic forms of how you store energy. Well, Einstein gave us the great equation, E = mc squared. A lot of people quote it. They don't really know what it means. But basically, it means if you have an amount of matter in stuff and you can find a way to convert all of this matter into energy, it's a tremendous amount of energy that can be released. And if you can store that energy and release it at will, you have the ultimate propulsion system. Well, in nature, things are made out of protons and electrons. That's normal matter. But under extreme conditions, all around us, nature produces a form of matter called antimatter. And that means you have an electron, which looks just like an electron, but instead of a negative charge, it's got a positive charge, and it's called a positron. And there are protons in normal atoms and things called antiprotons, which look just like a proton, have the mass of a proton, but instead of a positive charge, have negative charge. And when you bring those two atoms together, they annihilate and go boom, and basically produce immense amounts of energy in gamma rays, X-rays, and lots of energy you could use to drive a starship. And it's so energetic, in fact, that if you had a thimble full of antimatter and dropped it on a table in the middle of London, it would be worse than an atomic bomb going off, okay? The good news is we can use this to go to the stars if we control those energies. But what people may not realize, if you bring the banana slide back up, is that in your kitchen right now, you have an antimatter generator. And that's in your local banana, because the soil that bananas are grown in are rich in potassium. Everyone tells you need to eat bananas to get potassium, balance your electrolytes. Well, there's a form of potassium called potassium 40, and it decays into radon, into argon 40 about every 75 minutes, and it gives off one particle of antimatter called a positron. And that immediately annihilates with the matter in the banana and releases a little bit of energy. You won't measure it. It's not going to injure your health. Radiation's all around us, but it's natural and it's in your bananas. So if you want to drive that starship in the future, if you can figure out how to isolate all those positrons and store them, we'll have our star drive and we'll get to Alpha Centauri.
I love it. How many bananas would it take to get to Alpha Centauri, do you think?
Tons.
Thinking like, maybe I dreamt it. Is antimatter the kind of the most expensive thing ever because it's so difficult to make it? I went to CERN once and they showed me some antimatter in a thimble or something and said that's worth like a gazillion pounds or something. I can't remember what it was.
That's right. Antimatter is only produced under very energetic conditions, like at CERN. They make it at CERN.
Yeah.
And storing it is even more of a challenge because you have to have a perfect vacuum, no atoms of anything in the vacuum, and you have to keep the antimatter from touching the walls of the chamber. Really hard to do to store it. And globally, about a nanogram is made, but you need tons to build a starship. And if you had tons on Earth, it could destroy the planet. So I think we're going to build big antimatter factories in space before we go to the stars. So hold your bananas and just enjoy them for breakfast.
Maybe is it right that kind of all the kind of matter in the universe, the kind of baryonic matter is the kind of result of the matter-antimatter annihilation, and there was a little bit left over, and that's kind of us.
That is my understanding of the theory, that at the moment of the Big Bang, that there was a lot of matter and antimatter created, and the matter and antimatter immediately annihilated, but there was a little bit more regular matter than antimatter, and that's the universe around us. That's right.
And that's the limit of physics.
I think one of the big questions is, why was there an imbalance in the amount of matter and antimatter in the first place? And I don't think anyone necessarily knows the answer to that, but
Suzie, tell us.
It's a good question.
Yeah, I don't know.
Come on, Suzie, speculate. Wildly speculate for us, just for fun.
I don't know. There's some asymmetry, right? There's some asymmetry in the system early on, and I don't think anyone knows what created that asymmetry. I set a question to my students about radioactive bananas, Les, and I asked them if they should be afraid of a lorry load of bananas. But now I'm going to ask them how many bananas it would take to get to Alpha Centauri. So thank you for that inspiration.
I haven't actually done the math on how many bananas, but I do know that you'd have to have about a kiloton of antimatter. So right. I think we can translate that back to a good chemistry question with the decay rate of the potassium 40, and you got a final exam question in the waiting.
And you get extra points. How many pineapples would it take to destroy Alpha Centauri?
Yes.
Not too many.
Brilliant. Hey, if Sargunn is watching, this is great material for your next book. You can go into some deep physics using fruit-based analogies.
And then Eoin's asking, how do they create antimatter at CERN without bananas?
Well, that was my point. When I was there, I was like, what do you store it in? It's like, you say you make antimatter. Like, do you have like some kind of thermos flask? I can't remember. They did tell me, but I wasn't listening.
They make it by smashing the atoms. They accelerate these protons in opposite directions electromagnetically, and they smash into each other.
Yeah.
And when they smash into each other, you get all kinds of stuff that comes out. And sometimes some of the particles that come out are the antimatter particles. We actually, I was part of a team about 20 years ago that looked at how you might store antimatter. And we actually built a really, really good vacuum chamber and really strong magnetic field, because antimatter is a charged particle and a magnetic field can kind of trap it. And we were going to try to put some from the Fermilab Accelerator in Illinois, put it on the back of a truck and bring it to Huntsville and annihilate it under a controlled condition and measure the thrust in a little thruster. But the project never got funded to completion, so we were never able to complete it.
Honestly, that is the best idea for a sci-fi story.
So you were gonna create. Sorry, Dallas, I'm interrupting you.
But I imagine the truck driving from Illinois going to Huntsville, full of antimatter and terrible.
It was very little antimatter. We actually did the calculation that if the antimatter we had stored, like if the containment broke, it would be about the same radiation as you get in a chest X-ray when you go to the hospital. Wouldn't have been dangerous.
But for the sci-fi fans, you kind of go over a pothole and then terrible, the Earth is destroyed.
You're giving me ideas for a story. You better be careful.
This is my idea. Sorry, Suzie, I interrupted you.
No, I was just thinking about the sort of magnetic containment facility that you'd need and how easy it would be to put it on the back of a lorry. But you obviously thought of a solution to that. That's super interesting. So good.
Yeah, but we never got to do the experiment. It was actually kind of funny. We went to the people who regulate interstate travel of radioactive materials, like medical radiation treatments, and we told them what they wanted to do, and we fully expected to have them say, well, this is crazy. Yeah. But instead they said, oh, we've got a regulation already for how you transport antimatter. Go figure.
That's amazing. That's really cool.
Very happy. Do we have any more audience questions? Because I could just talk about this all night.
Just fun comments about the conversation. Joe Wise is suggesting that you could store the antimatter in the peel.
Yeah.
Sounds like the plot of a Half-Life movie game. And portable black holes.
This is a slightly off topic, but Les might appreciate this. Many, many years ago, well, in the 1960s, there was a British BBC TV series, a sci-fi series called Doomwatch, which very, very few people remember. And the kind of premise of Doomwatch was terrible things in science going wrong. And every week there was a sort of terrible thing, exactly as we've just described, your lorry full of antimatter blowing up. And the news last week, or whenever it was, of the, probe coming back with a bit of meteorite, with a bit of, and they opened it up. And that was a classic episode of Doomwatch. We need to bring that back, Les, I think, as a sci-fi writer.
Dallas, featuring Dallas Campbell, as far as I remember, actually.
This is, funnily enough, in the late 90s, we did a movie version for Channel 5. Channel 5 just started in the UK, and they wanted to bring back Doomwatch. And I got hired as an actor to play one of the main characters in this, one of the scientists, and my name as the scientist was Brian Cox. Weirdly, this was before Brian Cox was even.
Great. Well, there we go. Lots of ideas for Les. Please make a television. We'd love to support you. I just looked at the clock and realised that we are well out of time. So I think probably time for us to wrap up. But do join the after party. There'll be lots of opportunities to chat with Portia, to chat with Les, to ask all the questions that you need to ask them based on what we've just been talking about. So do join. There's a Zoom link there that you can click and join in. Before we go, there's SpaceBar swag. You can go to spacestore.co and you can buy SpaceBar t-shirts and hoodies and posters, and the profits go to Ocean Mind. So do support that. That would be great.
Don't forget to subscribe to all the social media things and the YouTube things and all the things that the algorithms like us to do. AstroAgency would be very happy if you did that. If you're giving a presentation and you're freaking out, give me a call and I will gently therapeutize. No, what's the word I'm looking for? Something. I'll therapy at you.
Yes.
Wait.
Dallas does presenter therapy. Give him a call. Otherwise, do join us next month. We're looking forward to the next session already. Thank you very much for joining us this evening. We really appreciate your company. Thanks for coming along, and see you in the after party.
See you on the other side.